Under the topic of motivation, the research question we will be discussing is, are there gender differences in school success, and what is the role of motivation in determining this success? Multiple studies, including those of Chechi, Williams and Barnett in 2009 and Martins, Herx, Maish and Wassenberg in 2011, have found women perform slightly worse than men on standardized maths tests. These studies have found gender differences regarding motivational variables. Girls and women generally show significantly lower self-perceptions and self-estimations in maths, as well as poorer expectations of their own success, but higher anxiety than males. For the purpose of the present study, the motivational variables were chosen from the expectancy value framework that's pictured, and only focused on students' characteristics for which gender difference have been found and that are related to achievement. Socializers and societal-related variables were neglected. The article I will be analyzing is Gender and Numerical Intelligence, Does Motivation Matter? The aim of this experiment was to examine the effects of the pictured motivational variables on the relationship between gender and numerical intelligence. There were five hypotheses. Firstly, math grades, maths ability self-concepts, which I'll be referring to as ASCM, self-estimated numerical intelligence, and interest in maths would positively correlate with numerical intelligence, whilst test anxiety would negatively correlate with numerical intelligence. Secondly, that math grades, test anxiety, self-estimated numerical intelligence, expectations of success, and interest in maths will influence the relationship between gender and numerical intelligence. Thirdly, that males will score higher than females in the numerical intelligence test. And lastly, that males compared to females will show lower math test anxiety, yet higher ability self-concepts, expectations of success, and interest in maths. The sample of participants in this study were 305 German students with a mean age of 17.5 and a fairly even male to female split from grade 11 to 13 across two high-scoring German schools. The research involved a series of written tasks. Students had to rate their own numerical intelligence from 1 to 7, answer 3 questions about their expectations for their results on the numerical intelligence test, complete a 4-item ASCM test about their talent in maths, rate how much they liked maths from 1 to 5, answer 5 questions about their anxiety levels, before lastly completing the numerical intelligence test. To test for the hypothesized gender differences, Hypothesis 2, a MANOVA or multivariate analysis of variance was conducted, with gender as an independent variable and the following factors in the circle as dependent variables. These descriptive statistics show that all measures had satisfactory internal consistencies, illustrating that other than anxiety, which was negatively correlated, all mediator variables were positively correlated with test performance. As you can see here, males rated their numerical intelligence higher than females, had higher expectations for their own success, and higher maths ability self-concepts. The gender difference in interest in maths was not statistically significant, but females scored higher levels of anxiety than males. Anxiety showed a negative correlation to numerical intelligence test performance, whilst all other potential mediator variables showed a positive correlation to numerical intelligence test performance. All hypotheses were supported, aside from the second hypothesis, as males did not show higher interest in maths than females. A limitation of this study is that the results cannot be generalized to students of different ages or countries, as the sample only included German students aged approximately 17. Students were from a high-scoring school and thus all had high numerical intelligence test scores. Future research could use participants of different ability levels. The results of the study were correlational, and therefore a causal relationship is out of the question. In future, an experimental design could be used to try to find a causal relationship between motivation and numerical intelligence. Despite these shortcomings, this research highlights the relevance of motivational variables in the field of gender differences in numerical intelligence testing. 5 motivational variables were used to investigate motivation more deeply than another study, domain-specific school achievement in boys and girls as predicted by intelligence, personality, and motivation, that used only 3, neglecting expectations of results and rating their own intelligence. By testing numerical intelligence and motivation on students in their normal school environment, the results are more likely to be accurate than, say, in a lab setting, as this is a real-world natural setting where numerical intelligence is tested and their motivation has impact. As the motivation tests were administered prior to the numerical intelligence tests, results represent some evidence of causal influence of motivation on numerical intelligence test results, even though the results can still only be interpreted as correlational. This research used quantitative data collection, which allowed for a large amount of data to be collected. An implication of this study is that as women had lower motivation than males for the numerical intelligence test and higher anxiety, reducing this anxiety and increasing motivation, such as their interest and self-perceived abilities, could boost their representation in the STEM fields where numerical intelligence is readily utilized. Further research should investigate whether women's performance on standardized numerical intelligence tests can be increased by means of different test instructions, as well as emphasizing that women perform as well as men on the following numerical intelligence test.